Awesome. Today we are going to be talking about object-oriented programming. Let me type. Okay. So Python and some other languages are called object-oriented languages. And in Python, since it's an object-oriented programming language, it has everything that you see, like a Boolean or a list or anything in Python is an object. An object is a collection of like data and methods that you can apply to that data. So object-oriented programming in general is a way for us to structure our code. So previously, we've been using functions, right? So if you need to do something with a program, you create functions that do certain things. And that's a typical like functional approach where you're structuring your entire program based off of logic, based off of like little pieces of information that you need to, little pieces of logic or computation that needs to happen. But with object-oriented, it is a design paradigm. So paradigm is like a set of like patterns or like a way of doing something. So object-oriented programming is a design paradigm that allows you to structure your program by bundling like related properties or data alongside methods that will do something to that data. So for example, you have a school. A school will have maybe instructors and classes and students. So if you want to encapsulate that to make it more, so to make it in your program be reflective of the outside world, that is what object-oriented programming allows you. So you can create, and we'll see how we can actually create these, but it basically allows us to make real world examples in code. So it allows us to use those examples to code in a more efficient way. It gives us like smaller, more reusable code. And I will kind of just start going into it, and then we'll talk a bit more about the specifics. So we want to create objects, and we want to model this object and kind of give it a blueprint so we can actually create it and use it throughout our program. So to do that, in Python and in other languages, we have something called a class. So a class is basically your template for the object that you're creating. And in this class, you can define whatever that class needs as attributes or functions. So let's say I want to represent dogs. So I can create a class dog, and classes are typically created with an uppercase letter in the beginning. So let's say this class dog right now won't really do anything. So I'm just gonna create this template, this class, and I'm going to instantiate it. I'm going to create an instance off of this class. And the way to do that, let's say this is my dog equals dog. So we do call it like a function, but this instantiates a version of this class. It makes pretty much a copy based off of the template that we created. Here, we didn't really provide any template, but this will instantiate what is it called? A class dog. So if we run this, we're not gonna really see anything. Python 3, .py. So nothing prints out, but we don't get any errors, so we're assuming that this works. So let's say we actually want to give a dog attributes, because let's say all dogs have legs, and all these legs, and let's say this is a generalization, most dogs have 4 legs. So legs, eyes, we know dogs have 2 eyes typically. And then I want to give this dog a function that will allow me to display the information in a more easily readable way. So I can say display info, and I will explain exactly what this means. And I'm going to copy over this print statement here. Okay. So now, when I create my dog, these here are going to be called class variables. Oops, that's not what I wanted to do. So these are class variables. Class variables are variables that you can use that will be tracked to your class in general. So if I wanted to say print my dog dot legs, it should tell me how many legs this dog has. Python 3. Okay, so it printed out 4. So one thing about class variables is that it is accessible to the instance. So here I created an instance of this class. So it has access to these legs, but also the class itself has access to it. I know this is a little bit confusing sometimes. So if I just said dog as a class, so these are just variables that are holding information for the class as a whole. These are not specific to my dog. It is the just as a whole, the class holds this information. So if I created my other dog, speaking like a pirate. So dog, this instance is separate than this instance. So every time you create an instance of something, that will hold the information for this one specifically. So right now, all the information is kind of shared, so there's nothing specific about this dog versus this dog, but technically this is an instance and this is another instance of dog. And again, dog is just a class, which is a blueprint for what a dog object should look like. So classes create objects for us. Any questions? Are we like on a good page? Is there anything that's confusing?
Daniel had a question in the chat.
Oh, yes.
You change the value.
So yes, you can set my dog to only have 3 legs. Yeah, we can say, actually, yeah, let's go back to that, but yes, you can change it. So if I say default chain or definition, sorry, change leg count. and this will have to take self. I will explain what it does in a moment. And then we can say legs minus equals 1. So we're just going to subtract 1. So if I say my dog dot change leg count. So these are called instance methods. So these methods are available to an instance after it has been created. So I created my dog, and then I had access to calling these functions. So if I do that, and then I print my dog.legs, we should see the number 3. Where is, oh, sorry. So to access this from inside, I have to say self.legs. So self is a keyword that allows you to reference the instance. It allows you to reference this object that has been created. And it says, okay, look at myself, look at my object, and find the legs attribute, and then use it. So if I run this again, we get 3. So one thing about class variables that is not always optimal, it is shared across the entire class. So it is not just attached to my dog, but my other dog also has access to the same legs. So if I wanted to change the leg count for my dog, my other dog will also be affected as well. So if I say, if I try to print out my other dog, the number of legs, because I changed the count here on one of them, both of them will change. So the legs will change for both of the instances. Because this is a class variable, it is attached to the class itself, so it will change and or not. Okay. Interesting. So what if I printed out dog.legs? Okay. Then I would probably, sorry, this was, okay. I understand what happened. So let me tell you what you want to change. Okay, so if we want to change a class variable, we want to say dog dot, what is it called? Like class, the class name dot legs, and that will change the variable for everyone. If we're using self, that's only changing it for the instance itself. And which is actually pretty good. Okay, so I had information that I was incorrect about. Okay, let's go back from the beginning. We created a class. So this is called a class definition, or an object definition. Let's call it class. So this is a class definition. We're defining a class. We are adding some class variables that we want to use. And we created a few functions that would allow us to interact with this dog object, basically. Whenever I create a dog, this is called an instance. So this is something that you need to make sure you notice the distinction of. So this is an instance of a dog class. And when you create an instance, then you will have access to the functions that that instance has. You also have access to the class variables. Sometimes there's a bit of weird interaction with the class variables. Like you saw here, if I use self, then it will only affect my dog. But if I do the big class name dot legs, if I subtract from that, it'll affect the class itself. So these class variables are a little bit versatile, where you can use them in a few different ways, which is a little confusing. So we typically don't use class variables unless we have to, we want to keep track of an overarching data piece that is attached to the class itself. So if I was creating a class for employees, I could have up here, I could have number of employees, and I could start it off at 0. And then every single time I added a new employee, then I could increment this number. And then whenever I access the employees, I would have an updated number of all the employees, which I can show an example of later. But basically, because of this, we typically want to keep instance variables. So that's whenever we use the self, like I said. So when you're creating a dog, it just builds this by itself. But what if you want to send in specific information for your dog instance? Here, we used a function called, a method called the dunder method. These are very specific to the classes. So all classes have some built-in methods that you can use. And these methods allow you to basically define the behavior of your class, of what it does. So we have something called an init method. So this is to initialize your instance when you create it. So here, let's say I want to create a dog that has a name. So I can't use the class variables because that is going to be shared amongst everyone. And not all dogs have the same name. So I can have, I can define self.name. And then I can define, we'll put it equal to something in a sec. So self.name, we can do self dot say breed. And we can say, what other attribute should we give the dog? We can give the dog color. Let's do that. Okay. So where are we going to actually get this information from? We have to send it into this function. So here, next to self, we can add a name that we're taking in. We can take a breed, and then we can take a color. And then we can just say this one equals that. Oops. Breed, and then color. Okay. So sometimes this is called a constructor. It basically, when you are instantiating an object, so if I'm doing my dog equals dog, when I'm creating an instance, this init method will automatically get called if it is there. If it is not there, it still gets called, but in the background. That's kind of like how you create a class. So if you define it, that means you're telling it to do a specific behavior that you want your class to have. And the specific behavior is to create these attributes to hold name, breed, and color of the dog. So now, let's see, if I run this, I get an error. So when I'm trying to instantiate it, it says it's missing 3 positional arguments, name, breed, and color. So now, because I've added this init method, it is requiring me to initialize a dog with these variables when I want to make an instance. So let's say my dog is called Bibo. What breed do we want this dog to have? Okay, you guys are too slow. I'm just
Corgi.
Sorry.
Corgi.
Corgi. I'll do that for the next one. And then color, let's say
Pink.
pink. Awesome. So now, if I want to see what my dog, I can actually just call display information. But now since I have extra information, I can add another print statement if I want. So let's say, my dog's name is, I forgot that I need to escape it. So to do that. So how can I inject the dog's name in here?
Self.name.
Yep. Self.name. And let's just say I only want to print that. So I can say, how do I call this function?
Dot display info.
Yep. So dot display info, and that will be called here. And it won't show me any of the other here. We'll just print. So my dog has 2 eyes and 4 legs. My dog's name is Bibo. So if I created my other dog here. Okay, so if I created my other dog here, what's this dog's name? Bart. I don't know. Corgi? No, Corgi. How do I spell Corgi?
I at the end.
Just an I.
Okay. And let's say this one's purple. So if I do my other dog dot display info. So the top one, it's going to be the same because we didn't really change anything specific to that dog. But it will have context of who that dog is based on the instance. So I created an instance, and now this instance of this object of dog has these attributes. And so when I use any of these functions, it will have the context of this dog specifically, versus when I created this one, it created it with another set of information, and this dog will now have the context of this information only and not this information. Any questions?
Yeah, I have a quick question. I forgot if you can do default values in the class initiation. Can you do that?
In here? Yeah, you can have defaults. So
Okay, got it.
yeah, if you're taking something in, you can just say name. If no one provides a name, you can just say it's something, I don't know. But then you have to also add, oops. Yeah, you have to specify it. I'm not sure why you have to specify it for every single one.
I think sorry, the default has to be the last parameter.
Oh, okay. Okay, so I guess if you set the beginning one, you have to set it for every single one afterwards because of how positional arguments work. So if you specified that this one has a default, that means that you can not include it. But if basically you have to create all of these to have like a key type argument. So you have to specify when you're sending it in that Bibo is name, basically. Oops. And so on. And the rest, breed, color, those are also in there as well. Any other questions?
Yeah, I just was wondering what that arrow none is doing on the
Oh,
image.
yes, this was added automatically with Python. This is a way to specify what the output of a function is. It is not needed. So if I take it out, everything would be completely fine. It is not specific to this one function. I can add it to any function that I want in Python in general. So it doesn't have to be within a class either. And this just specifies what am I expecting the output of this function to be. It's Python's way of doing like typing. Typed languages allow you to specify, I think Benjamin mentioned like TypeScript when we were talking about JavaScript, and TypeScript basically just allows you to specify the type of variables and functions to minimize errors. So in Python, this is their way. So if I want to make sure that my function returns an int, I can do this. So when I'm running it, it'll be like, hey, you're supposed to be returning an int here, but you're not returning anything. So that's just like a way of error checking. But it is not needed. It was an automatic, like an auto completion thing. Other questions? Also, valid questions or valid comments are like, could you go over the entire thing again? Or like, could you rerun through this?
I have a question about your change leg count.
Yeah,
So is it doing it on itself or is it doing it on the class?
this is doing it on the class. And then if you wanted to do it on the self, it would have to be on self. But basically, if you have a class variable that lives up here, that means that you can access it through the class itself. So people tend to not use instance attributes kind of like this. They don't tend to use it outside of the initializer. So here's where you set everything, and it has context of that instance. So yeah, typically people use class variables for keeping track of something that a class needs as a whole.
Right. So if you instantiate an object and then change the class variable,
Mhm.
does the instantiated objects variable update?
So if I instantiated a class, you said, and I changed the class variable or the instance?
The class, I guess I'm wondering if you update the class, does it automatically update all your instances or
Yes.
only your instances?
No, it does all the instances. So let's say for my dog, I'm gonna call change leg count, and this is accessing the class variable. So when I put self here, it transforms it into an instance variable. So an instance variable is just tied to your specific instance, and self refers to that instance when it is called. So when you do my dog dot, the self is automatically tied to my dog when you're calling it. So if I change the leg count and then I'm gonna print the legs, let's see. I'm gonna keep it as class. I'm going to just clean up. I don't need to display the info for this or this right now. So yeah, so change leg count up here for this dog, and then I want to print out the legs for this dog, and then the legs for my other dog. And then I want to print out the legs that is attached to this class instance, this one here. Okay, so let's run it. So when I changed it, when I subtracted 1, it changed all of them. So let's see what happens if I change this to self. So it only changes that one dog's instance that we wanted to change. So here, my dog is the only one that has the -1, but the class itself still has 4, and the other dog still has 4.
When it comes to class versus instance stuff, basically think of it, because it is this way, like there's only one version of the class. There's only ever one version of the class, just like a regular object. If you make a change to it, you know, all of these individual instances, they're referring to that same class. So if a class variable changes, it's going to change all of them just because they're all referring to the same thing.
Mhm. Yeah.
Okay, thank you.
Of course. And Leo, you're asking, is it best practice to do one over the other, or is it situational? I believe, I'm not 100% what the latest verdict on this is, but I believe you should use instance methods for most things. So typically anything that is attached to your specific instance should be an instance method or an instance attribute. But if you're using something that will be tracked for everything, for the entire class, then you would use a class variable. I don't typically see people using a class variable and then modifying it like an instance variable.
Yeah, think of it like just like if it was a real world thing. Let's say you had this idea of a class of dog versus individual dogs. Well, individual dogs might have 4 legs, but some, dogs could end up having 3 legs. Whereas like if you wanted to save like the Latin name for dogs, well, that's going to be true for any dog, right? Has nothing to do with the individual dog. That's true for all dogs. So only in the case where it's true for everything and the individual never differs, does it make sense for something to live in the class versus the instance.
Other questions? No? Okay. So, quick recap. Class you can use to make a template, basically, to define an object. So you want a specialized object that you want to use throughout your program, you create a class for it, and this class will then hold attributes. So there's some class attributes, there's some instance attributes, and then it also holds methods that can interact with this, that will allow interaction with this, this object. All right. Let me see. I worked through quite a bit of the thing. Okay. So yeah, we talked about the methods. If we want to, sorry, one sec. Yeah, anyone have any questions about this self? So
I'm interested in Dan's question too. So what happens if you change the instance of legs, later change the class legs? That will, if you change something in the class, what, overwrite something's in the instance?
yes, so that's what we did earlier. So when we,
I didn't see that.
so when we did, what is it called? So here for this one instance of dog, we changed the leg count. Right now it's we have it to be the instance, but if we had it be the actual class dot legs.
Right. But if we had 2 different functions in there, one changes it in the class and a second function later changes it.
I see. Okay.
First, which one takes priority? Or will it rewrite?
It will rewrite it basically. Yeah. So let's say change class leg count. So this one and then this one is just for the instance. That makes sense. Okay. So let's say I change leg count for this dog. So this dog has 3 and this dog has 4. So let's say for here, I can just print these out and then we'll see what they are. And then I can call just any of my dogs. So my dog dot change class leg count. And then we can print all of these out and we can see what happens. Okay. So for this one, so for the first set, we only changed the leg count for the specific dog. So only that dog had 3 versus everyone had 4. So my other dog had 4 and then the class itself still had 4. But when I changed the class leg count, so I changed it to 4, then everyone became a 3. Let's say I did this not for my dog, but for my other dog. Okay, then I can run this. It would do the exact same thing. So when you change the class variable, it will change it for every instance of that class. It'll be like a universal thing, pretty much.
Thanks.
Zainab, I think at some point we're going to teach the idea of a static method, right?
Yeah, I think that's either tomorrow or the day after.
Okay, so Dave, once we get to the static methods, things might be a little more clear because sort of like in you could have a class variable in terms of like this, like if we're saying dog.legs, that's a class variable. It's right on the class. It's not on instance things. Just like that with a function, you could have a static function, which means you're not going to call it as, my dog dot change leg count. You're going to call it as, dog dot change leg count. So basically, static and class variables kind of go together where, I mean, ideally you shouldn't be naming things the same thing anyways, but like if you want to change something that's for the whole class, there's a way to do it. And if you want to change things for the instance, there's a way to do it. And usually the two don't get that mixed together. We just haven't gotten to that second idea yet.
Yeah, thank you, Ben. That was great. That was a great thing to point out. Yeah, so I'll remove this because this is a little confusing. So based on what Benjamin was saying, this would be the static method or the class method. Actually, I think they're two different things, but we'll talk about those tomorrow. But yeah. So this typically would not be here. And we would only be accessing instance stuff with these methods that have the self sent into it. Great questions, guys. Any other questions?
Mason had a question in the chat about this.
Sorry, one sec. Would the instance have to have this legs equals legs? No, so you don't have to actually specify. So if the variable is up here, it is automatically included when you create an instance. So the instance will have access to it, even if you don't put it inside of the initializer. This is technically initializing it. But so here, when I created my dog, I'm able to do my dog.legs, even though I didn't include it in here. Does that make sense, Mason?
Yeah, that makes sense. I'm just trying to go back to like, okay, all dogs have 4 legs, yeah, but like my dog may have 3 legs. So when you push that or instantiate that object or class, you can still pass the legs in there. So my instance of that class
Yes.
would have 3.
Yes. So let's say if I wanted legs to be optional. So And if you specify legs, so if legs, so if it's not none, then you can say self.legs, oops, equals legs. Yeah, so you can overwrite it. If you want to, yeah, so we wouldn't want to change it necessarily. Well, in this case,
So what I'm kind of getting at is like, I wouldn't, like, the use of legs up there. You know, like if legs is a variable of the class,
Mhm.
right? But as you pass in the legs, I guess, you know, it would be normally like in a form or whatnot, but yeah, I guess I'm just trying to say, like, is legs up there being a static variable even necessary? Or do you want the option to be, hey, not all dogs have 4, so we'll just leave it in the dunder init
yes,
for the option for the user to pass number of legs, it not be static all the time?
yes, that's what I would do. I guess the legs thing is not a good example. Maybe it would be like has a torso or something like that. But yeah, I agree. So if you want to allow the changes, you might as well just have it in here. So I can say self dot legs equals 4. It could equal 4, or if there is legs, so then it would equal that. So you would just have the logic in here to do that, to handle that.
Awesome, thank you.
I guess I'm a little confused when you have the two statements at the bottom there in the console. I'm confused as to why it's 3, 4, and 4, and then 3, 3, and 3, rather than 3, 4, and 4, and then 2, 3, and 3. Why did it just completely overwrite what you did earlier?
So it's not 2, 3, and 3 because it overwrote. So this one, it overwrote the 4. And the 4 then updated. Let me see. Let me do -2 for this one. Let me actually see if it actually subtracts an extra one from the other one. So if I run this. Okay, so this is probably what you were. I think the 3 was there from before because we subtracted it, so that became different. But so for my other dog, I didn't change its instance, its legs up here. So up here, where is it? Up here, I only changed the first dog. I'm actually going to change the names of these because it's hard to. I'm going to copy this. Okay, and then this one is Gart, which is, I think, a very funny name. Okay. So when I instantiated Bibo, I changed the leg count to 3. So when we were printing these out, 3, the other 2 were unchanged. Here, I changed, so you can ignore this part because we're not actually using the self. So in this method here, we're not using the self. That means this is not really attached to this instance. Rather, we are changing the class variable itself. So imagine this is not here, and we're just calling this function as a regular function that changes the class variable. So when I did that, it subtracted by 2. So that means everything attached to dog.legs has become 2. But because my first instance, the Bibo dog, because I subtracted that by 1 already, that became its own thing, that became attached to the instance versus it's taking from the class variable. So I don't know the internal mechanism in Python, but basically this became out of sync pretty much. So when I'm trying to, when I did this, change class leg count, so even if I do Vibo here, I should get the same thing, which I did. Yeah, so this change class leg count subtracted from the class leg count, which then, because it's subtracted from the class leg count, any instance that still takes from the class leg count that has not been modified yet is going to reflect that change. That is why it's a little dangerous to use these class variables unless you're using it specifically to track something that is not attached to instances, because things can get out of sync. Did that clear it up?
Yeah, I thought it was like completely ignoring the instance change, but the minus equals 2 there, actually, it helped a lot, so thank you.
Awesome. Of course. Other questions?
Can you add can you modify the value inside of class when you call outside?
Can I modify what in the class?
Can you add the value of the legs after you call the function outside of the class?
Yeah, so I can do, like, let's say I already created the class and it didn't have anything about legs, or let's say I want to add a new attribute like tricks or something like that. So let me see if I can do that. I think you might have to define it previously. So add tricks, and this is going to take in the self. Oh, please. That happened by accident. And then I can say self dot tricks equals empty list. Let's see if that works. No attribute leg count. This is just trying to call this function that I commented out. So no issues there. Just delete that. Okay. So I'm not printing anything out because I'm still printing these out. But it didn't cause any errors, which is good. I didn't call the function either, so it's possible it didn't work. So let's see. We're gonna print my forgot it's not my dog anymore. Dot add tricks. And then I'm gonna say print people.tricks. And let me try to print that above as well to see what happens. Okay, so dog has no attribute tricks when it got to this line. So after I called the function, it created an instance attribute, and then I was able to access it. So you can add stuff later on. You just have to be very specific in your code when you're trying to call and use those attributes to, like, you have to make sure you add them first before you try to access them.
Got it. Thank you.
Questions on this? No? Okay. Let's see. So I was going to give the example of the tricks. So yeah, let me show you an example of how we would use these, like the class variables, pretty much. Because we know how to use the instance variables, they're just attached to an instance and you can define them up here. But like, why would we need a class variable, or how could we do that? So class var example. And I'm going to grab this. Okay, so let's say we have an employee class. Our program uses has a need for employees or an employee object. So let's say we defined the init method with just first name, last name, their pay, and then we created an email based off of their first and last name. Let's say that's just how emails work. So you notice here, we have two class variables, and let's say the raise amount will always apply to all employees, and number of employees is going to be held for all of the, for the entire company. So this is an example of where you would use it. So if I had, if I then created an employee, let me grab these examples real quick. Okay, so if I create an employee, right, I initialized it, and then I'm going to create another employee, and then I'm going to see the number of employees after every time. So if you notice in the initializer, we are incrementing the class variable here. So every time we add a new employee, you're just adding to that. So if I run this is not the right file. Class, for example, I'm not printing this out either, so that is important. Okay. So you see here, first it was 1 and then it became 2. So this is a way to keep track of things that are attached to the class. So in your program, you have employees and you want to, like, where would you hold the number of employees? You can create another class maybe for company and that would hold the information. But if you didn't actually need that extra class, you can just hold the information in here and then you would access it to see how many employees do I have based off of my employee class. So that's one of the ways to do it. Let me think if there's another way. Yeah, there are some other examples, but yeah. Let me see. I think I missed a few things.
There's also always just the option of normal variables in that if you wanted to track the number of employees and you have this class called employee, you could always just have a variable that keeps track of how many employees you created. Yeah, I don't know that maybe that's like an obvious or dumb point, but don't think of a class as something you have to use all the time. If it fits the situation, great. But like all these things you learn, they're essentially tools, and trying to use a hammer when it's unnecessary, or when a hammer is needed, but you try and use like a sledgehammer, that's not actually a good idea. You want to use the tool that fits the job. So sometimes a regular variable is all you need.
Yeah, I do agree. So yeah, you don't need to have this in here for sure. Some people do use it in this way, and this is an application of the class variables.
I have a quick question related to that. So with number of employees here, obviously we're incrementing it by 1 every time we create an object of this class. Can we like deinitialize an object? Like, can we destroy it?
There might be a method for that. Let me see.
Like if you got rid of an employee, how would you change that?
Yeah, the delete one. So __ delete DAL. This is a destructor, and you can it'll be called when the object is going to be deleted. So you can do that, but Not
In a
sure.
language like Python, you're generally not going to be the one in control of when something is deleted. It'll get deleted when you no longer are referencing it at all, like you have no variable that points to it. But I would say, like in most cases, if you want to delete something, it's more that whatever you're using to keep track of it as existing, like let's say you had a list of employees or a dictionary of name to employee. Well, that employee could have a value in it, like currently active or fired or something like that. And that's how you would know whether it's really existing or not, versus something like this, which is more like essentially unique to, or like it's about the specifics of whether a computer is keeping track of it in memory or not. And that's almost like that's not a concern as a Python programmer. You really need to think about that much, like the fact that it's eventually going to disappear from memory. So hope that is relevant.
I think so. I think it is. Yeah, you typically don't care much when something is being destructed. There's a question, Daniel, you're asking, you understand it's a good example of a class level attribute. Wouldn't employee type of info be better suited in a SQL database or something for persistence? Or is there a way to create persistence with class by saving it to a non-SQL file or something like that? So persistence and object-oriented programming kind of work together. So persistence is basically putting your data somewhere to be held, to be saved. So classes help you when you're developing your program. So classes help with the organization of things. It helps you model the object as closely as possible so you can use it in your program in such a way that seems more realistic, more natural. So you could have an object, so you could have a class here that holds employee information, but if you want it saved for later, you will have to use a database or a file or something like that to actually save the information. So they end up working together. Sometimes they model each other like closely, so they're very like similar in the same attributes that you're holding. But the class here, this is for use within your program while you're writing the program and while you're developing, pretty much. Versus persistence is when you want to save the information for later, so you can probably have this class take the information that it has and then pushes it to like a database somewhere, or puts it into a file that you can then reuse.
And this will come up later in the course once we do Django stuff. This is what you're referring to is what's called an ORM, or an object relational mapper. Basically, things like to exist in one way when they're in SQL, and that's great for storage, and they kind of like to exist in another way when you're working in Python, which is in the form of objects. And this is a library that basically makes it easy to go back and forth between those two forms.
Yeah. Does that make sense, Dana?
But really good question. Pretty advanced, but pretty, very, very good. You see where things are going.
Awesome. Cool. Other questions? Okay. Okay. Yeah, this lesson is not too super long. Trying to see. Okay, so there are. So I mentioned the phrase dunder method. Dunder's just dunder spelled like dunder. It just stands for double under. So double underscore before and after this function. So these are specific functions that are available to us through Python, and they are built-in methods that we can leverage. So what is it called? Yeah, we won't be covering what all the Dunder methods do, but I do have a link that I want to show you that kind of goes over a sec. And this is in the lesson as well, so you guys can actually go through them. So there's a bunch of them that are defined. So a simple example to understand, I think they will let you understand a little bit what Dunder method is. But basically, when you're adding something to something else, a lot of times it uses, or I think most times it uses the underscore add or the Dunder add method. So when you do like an actual plus, since this is a class and this is a class, this int class, this number class, has defined how you can add two things. So if you're adding two strings, you're able to concatenate a string, right? So it has this string plus this string. How does it know not to try to add it like numbers? Because that class probably has a Dunder method add that is defined that tells it how to add these two lists. Add these two strings. Same with a list. Like if you have these two lists, it knows how to automatically do that. But it's not automatic built into the plus sign. It's actually like an overwrite of this add method. So these are ones that exist. I will show you how to make a few. So let's say you want to print out your employee in an easier way. So you can have like a function that does like kind of similar to this one, like display info. So if I say, display info, and this one could then return a string, or it can print a string or something like that. And that string will hold all of this information in a prettier, in a way that's formatted better. So you can say name, I want to do, nope. So this would have to take self because I'm creating it in the class. So I can say self dot first name, comma, self dot last name. And if I print employee1 dot display info, I forgot to call the function. So here, when I printed that out, it just printed out what is this, like what is display info, and display info is a method. So when I actually call the function, then it will display what it returns. So here, this is the name, first name and last name. But let's say we don't want to call it with a function. We just want to be able to say print employee1. So how would Python know how to print this object? Like when you have a dictionary or a list or something like that, and it automatically knows how to print something. So if I try to print my dictionary, it prints out the dictionary. If I try to print employee, what will it give me? What do you guys think? Any guesses?
The memory address that it's stored in.
Yeah, wait, I didn't run it. Yeah, it gives what is this object and where it is. So it just gives you some information. Like this is an employee object, that's sometimes helpful, but you don't really, that's not really what we're looking for. We want it to print out the information like this. So there's a dunder method that allows Python to that allows this print function to identify this employee by something else. So instead of just returning this, I would want it to return this. So the dunder method for that is __ str for string. So this happened automatically. Like I said before, this is typing. So it specifies that I need to return a string for this method. So I can remove it, I could keep it, it doesn't matter. But basically, I want it to return this. Okay. So now, when I run it, instead of seeing this, I will now see whatever I specified it to return. So these functions pretty much do like an override of the basic functionality of something. Same with init. If I didn't specify it here, it was just going to initialize an employee as like a basic class. Like it won't add anything special or do anything special. But because I identified it here, it can do whatever I want it to in here. Any questions on this one?
Yeah, I have a quick question.
Yeah.
In the init method,
Mhm.
can it, when the class is instantiated, is it good practice to put or to call other class methods from the init function?
Other methods? Yeah, you can. Like if you had, yeah, let's say for one of them, self.role, and you needed to do some sort of some sort of logic that determines that person's role, then that could be in a separate function, and then you can say self dot apply raise or something like here. Yeah, whatever function that is available. So if you write a function that determines role, so determine role, then you can call it and have it do what it needs to do to define that.
Awesome, thank you.
Awesome. Other questions? I want to, this resource is a little hard to see, but I could do the same thing if I wanted to say employee plus employee, and I wanted it to do some weird, like maybe I wanted it to concatenate the two names. Then I could, here, let me show you how to do this. So I define the string one. Let's say I want to define what the add functionality will do. So add is going to take two arguments, self and other. So basically the object before the plus and the object after the plus. And then let's say we return self.firstname plus, so I guess I'm adding too many pluses, but I can, let's say, let's return a string for this one. So we can format the string and we can say, oops, self.firstname, then just do this. And then other.firstname. Not sure why.
First, missing a T in the second part.
Oh, thank
Missing
you.
a T.
Still not coloring it, but it's okay. We'll yeah, we'll see if it actually runs. So I can actually print employee 1 plus employee 2. This is causing an issue. Yeah, you guys know when you get issues, always read the bottom of the entire error, and that's where it's going to be the latest like what is happening here. And if it doesn't really make sense, you can also see what line it broke at. So we saw here, it's in my class var example file on line 11. Line 11 is here, and that was the issue. And there we go. So I did employee 1 plus employee 2, and that now returned just the first name and the other first name with like 2 dashes in front of them. So these are pretty cool. You can look to see what is available, what you can play around with. I think there might be one to transform your object into a dictionary. I don't remember how to exactly use it, but it is also one of the available ones. And I'll try to find something that's a little more human readable. I feel like these examples are a little distracting looking. Okay, let's take a break. We're 10 minutes over the hour, but yeah, let's take a little break and then we'll come back and see what else is left.